Alright, so we're going to start with what type of transformation is the following. So we're going to be doing this page by page. I'm going to start with this first page of the unit, and then whatever page you need to, jump to that exact page, okay? But first, let's look at this first one, okay? So, as you can see, we got two objects that look like the same shape but different sizes, okay? What we call this when it goes from large to small or small to large, alright? It's called a dilation, alright? That's all I want to know is, what is it a dilation? Yes. Okay. I don't need to know the exact size or anything like that. I just need to know, hey, it's a dilation. Alright, so that's all we're trying to look for in this first part, is what are the transformations called that's happening? And the second one, going from 1 to 2. Well, you'll notice that this thing changes orientation, alright, meaning it shifts, and it moves to a different spot. Well, reflection, alright, so let's rule out stuff that we don't know, or that we know it's not. Reflection usually reflects it, and it looks like essentially the mirror opposite, okay? But from 1 to 2, it doesn't look like a mirror opposite. It can't be a translation because it didn't change, alright, it changed orientations, right? So from 1 to 2... From 1 to 2, it changed orientations, meaning it turned a little bit. Alright? Translation just moved the object. It stays the same orientation, but just moves the object. Can't be a dilation, alright, because it didn't get bigger or smaller, so that leaves one thing only. It's a rotation, meaning it moves from here to here. It rotates, okay? So it went from this quadrant to this quadrant and rotated. So that's our first part, is it first rotates. So it's rotation. Then the second one, from 2 to 3. Okay, so from 2 to 3, what happens is, we're looking at this from 2 to 3. It doesn't look like an exact reflection, so it can't be reflection. It didn't turn like we did with this first rotation, but it did move. It stayed the same orientation, but moved to here. So remember, that's called a translation. So it went first rotation, then translation. Okay? So first rotation, then translation. This next one. Alright, so from 1 to 2. Now, once again, let's figure out what we did. So from 1 to 2, it doesn't look like we rotated it. Because usually when it's rotated, it stays in the same part. Like up here, where if I show you, from there to there, it essentially stays in the same spot. Okay? It's just like rotating around the circle. It's like this arrow is rotating around the circle. Well, this is not really rotating around. It just kind of reflects. So you'll see from 1 to 2, it just reflects across the line. So reflects. This is a reflection. Okay? Now, from 2 to 3 is two possible options. Okay? So, most commonly, people are just going to think of this as a translation because, hey, it just moved from here to here. It went from here to here, so it just moved. Well, that's one way to look at it. All right. Now, what I should have done is actually put the letters on here so that you could see, because that would really give you a definite answer. But when you see from 1 to 2, okay, so that's a reflection. From 2 to 3, since I didn't put the letters on there, there's two possible answers. One, you could either take this and move here and call it a translation because it just moved, or you could look at it as like this. We rotated it 180 degrees. So we moved it from here, all right, to here, 180 degrees. Notice that all the points, okay, where it's at in the whole thing is if I turn this upside down, okay, it looks like that. And that's in about the same place where this one would be. So you could either put, the second one could either be a rotation, or it could also be a translation. Okay? Wasn't very specific on it, so I'm going to say rotation or translation. Either one would work. Now we have this next idea from 1 to 2. Okay, so from 1 to 2, so it changed orientations, so that and it doesn't look like a mirror reflection. So it can't be translation, it can't be reflection. So usually it's probably going to be dilation or rotation. Well, it didn't get bigger, it didn't get smaller, it just moved like this. So first thing would be a rotation. Then what happened? Well, if you see this, it flipped. So when something flips, it means that it's the mirror opposite of the other object. Okay, so when we see it flipping like that, it would be a reflection. Okay, so that's how you define what type of translation. That's what you're going to do in the test. Is the first part's going to be like, what are you doing? Are you translating, rotating, doing what? What is each object? And I think the first part is multiple choice, so it shouldn't be too difficult to do. All right. Now let's get into the first part of our transformations. The first thing is translations. Okay, so translations. We got to remember a couple of different things. The first thing we got to remember is that when we are adding to the x, okay, x plus a number, we're going right. Okay, when it's x minus a number, we're going left. Y plus a number, we're going up. Y minus a number, we're going down. Okay, so that means that each point is going to either go right or left and then up or down. So here we have x minus 3. Well, x minus a number means it goes left 3. So we're going left. Then y plus 4. Well, y plus means to go up. So that means then we're going to go up 4. So that means you take each point. Okay? This point right here tells you go left 3. 1, 2, 3. And it tells you go up 4. 1, 2, 3, 4. Then the next one, you go over 3. 1, 2, 3. Then you go up 4. 1, 2, 3, 4. Once again, you go over 1, 2, 3. 1, 2, 3, 4. Okay. Now we just translated the unit. To the left 3 and up 4. So the left 3 and then up 4. Okay. Next one. X plus 2. Y plus 5. Well, x plus 2 means we go right. Y plus 5, y plus means we go up. So it means each point is going to go right 2, up 5. So we go right 1, 2, we go up 1, 2, 3, 4, 5. Right 2, 1, 2, up 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. Alright, we're going to keep doing this until our shape looks like this. Okay? Okay? So it's not perfect, but it's close enough. Alright, so this object went to the right 2, up 5.